There is a place in the Australian Outback where the ground itself remembers fire falling from the sky, not as a legend passed down loosely through centuries, as a name, a literal, specific name, still spoken today, that translates to Sunwalk Fire Devil Rock. That name belongs to a cluster of craters in the Northern Territory called Henbury, and the people who named it may have watched it happen. Here's what makes this different from almost every other impact site on Earth. Most craters are silent. No one alive remembers them forming. No culture preserved a memory of the moment rock and fire tore into the ground. Henbury is different. The oral traditions of the local Aboriginal people describe a fire devil that came down from the sun and struck the earth, warning that anyone who drinks water from the crater will die. That's not a vague myth about the sky. That's a specific, detailed account of a fireball descending and striking ground that still exists, that you could walk to today. Geologist and cultural astronomer Dwayne Hamacher, who has spent years studying the intersection of Aboriginal oral tradition and documented natural events, has argued that Aboriginal accounts of the Henbury craters likely represent one of the oldest surviving human eyewitness memories of a cosmic impact anywhere on the planet. Not a myth loosely inspired by craters someone stumbled across generations later. A memory, passed down generation to generation, of something people actually saw. To understand how rare that actually is, consider how many impact craters exist across the planet with no accompanying human story at all. Scientists have cataloged well over 100 confirmed impact structures on Earth, ranging from small pits to massive basins hundreds of kilometers wide. The overwhelming majority carry no oral tradition whatsoever, either because they formed long before humans existed or because whatever community witnessed them never survived to pass the memory forward or simply lost the story somewhere along the way, as so many stories eventually are. Henbury belongs to an extremely small category of impact sites, where the human account and the physical evidence still exist side by side, checkable against one another, almost like two independent witnesses to the same event, finally comparing notes across thousands of years. Let that settle for a second. Somewhere between 4,000 and 5,000 years ago, based on geological dating of the site, a cluster of meteorite fragments tore through the atmosphere and slammed into the central Australian desert with enough force to blast more than a dozen craters into the landscape, the largest stretching nearly 200 meters across. And there is a real possibility that human eyes were there to see it happen. An event like this doesn't announce itself gradually. A meteoroid entering the atmosphere at that scale would have appeared first as a point of light, brightening within seconds into something far more intense than the sun, before fragmenting under atmospheric pressure into the multiple pieces that eventually created the separate craters scattered across the Henbury site. Each fragment would have carried its own violent arrival, its own shockwave, its own plume of dust and vaporized rock thrown skyward. Anyone within sight of the horizon that day wouldn't have witnessed a single event. They would have witnessed what must have felt like an entire volley, impact after impact, as though the sky itself had opened fire on the ground. Try to imagine what that actually looked like from the ground. No warning system, no satellite tracking a fireball's trajectory, just an ordinary day, and then, without explanation, a streak of light tearing across the sky, growing brighter, faster, louder than anything in a person's entire framework for understanding the world. Then the ground itself convulsing, a shockwave rolling outward, dust and fire erupting where solid earth used to be. If you were standing anywhere near that impact, there would have been no context for what you were witnessing. No word yet invented for meteorite. Just an event so far outside normal experience that the only way to process it was to build a story large enough to hold it. And that's exactly what happened. The story that emerged wasn't calm scientific observation. It was a warning wrapped in fear, passed down with enough seriousness that it survived for thousands of years. A fire devil descended from the sun. The water inside the crater is poisoned. Stay away. Here's the part that should genuinely surprise you. That warning wasn't wrong. Modern geological analysis of the Henbury Crater Field found elevated levels of nickel and other metals associated with meteoritic material contaminating the local soil and water, consistent with debris from the impact itself. In other words, a warning passed down through oral tradition for potentially thousands of years, describing water at the site as dangerous, lines up with an actual measurable geochemical hazard. This wasn't superstition dressed up as fact. This was empirical observation, encoded into cultural memory long before anyone had the scientific tools to explain why it was true, and preserved accurately enough that it still checked out when researchers finally tested it. Dating a crater like this is its own painstaking process. Scientists can't simply guess based on how eroded a crater looks, since wind and rain shape different landscapes at wildly different rates. Instead, researchers rely on techniques like measuring the accumulation of certain isotopes in exposed rock surfaces, which builds up at a known, steady rate once material is exposed to cosmic radiation for the first time. Applying that method to Henbury produced an age estimate placing the impact within the last several thousand years, squarely within the window when humans were already living across the Australian continent. That timing is exactly what makes the oral tradition so remarkable. This isn't a story invented long after the fact to explain a mysterious hole in the ground. The chronology actually supports the possibility of a lived, witnessed event. That should change how you think about oral tradition altogether. It's easy, from a modern vantage point, to assume ancient storytelling was just entertainment, embellishment, myth for myth's sake. But here is a direct case where a story functioned exactly like a warning label, practical, accurate, and specific, surviving intact across an almost unthinkable span of generations purely through the discipline of careful retelling. Henbury isn't the only place where this kind of memory shows up either. Researchers studying Aboriginal astronomical knowledge across Australia have documented other oral traditions describing fireballs, falling stars, and impacts at additional sites, suggesting a broader, sustained cultural practice of observing and recording unusual events in the sky, then encoding them into stories precise enough to survive intact for millennia. This wasn't a single lucky coincidence of memory. It points to something closer to an oral scientific tradition, one that used narrative instead of written text as its method of data storage, and it worked. Compare that to how fragile written records actually are. Paper burns, ink fades. Entire libraries have been lost to fire, flood, and war within mere centuries of being written. And yet, a story told around a fire, repeated by voice alone, generation after generation after generation, managed to preserve an accurate, specific, testable piece of information for potentially thousands of years longer than most physical records could have survived. That's not a lesser form of knowledge. In some ways, under the right cultural conditions, it may be a more resilient one. This isn't unique to Australia either, which makes the pattern even more compelling. Researchers studying oral traditions in other parts of the world have documented similar phenomena. Communities near other ancient impact or volcanic sites carrying warnings and origin stories that, once cross-checked against geological evidence, turn out to describe real events with startling accuracy. Coastal communities in various regions maintain flood and inundation stories that geologists have since connected to actual tsunami events recorded in the sediment. The pattern suggests something bigger than a single lucky case at Henbury. It suggests that structured oral tradition, in the right cultural context, functioned as a genuinely reliable method for preserving observational data about the natural world, one that modern researchers are only now learning to take seriously as a scientific source rather than dismissing as folklore. Now think about what it must have taken to keep that story accurate for so long. Oral tradition isn't a game of telephone, degrading with every retelling by accident. In cultures with strong traditions of structured storytelling, specific roles existed for preserving accuracy. Elders responsible for teaching the next generation precisely, correcting details that drifted, treating certain stories with the same seriousness a modern archive treats an original document. The Fire Devil story wasn't casually passed along. It was maintained deliberately, because getting it wrong carried real consequences. Drink from the wrong water, and the warning existed for a reason. This kind of transmission also relied on repetition tied to place. The story wasn't just told anywhere, detached from context. It was very likely told at or near the crater itself, reinforced by the physical landscape every time it was retold. The scorched ground and strange sunken shape of the earth serving as a permanent visual aid no written page could offer. Every retelling happened with the evidence standing right there, which may be part of why the details held together so precisely across so many generations. The land itself became a kind of co-author, keeping the story honest in a way that pure verbal transmission alone might not have managed on its own. There's something almost dizzying about standing at the edge of that crater today, knowing what might have happened there.